Muito bem, pessoal, sejam todos bem-vindos novamente agora no segundo período do dia, hein? E agora, pessoal, teremos uma super apresentação. Vou trazer um colega aqui na continuidade desse super evento que está rolando faz 2 dias, não é verdade? Para quem está acompanhando, né? Enfim, o evento está sendo gravado para que vocês possam depois assistir, possam, né, colher bons insights. Mas vamos lá, para a gente seguir com a nossa programação agora, eu vou chamar um super colega aqui ao palco, Mihail. Deixa eu ver se ele está pronto. Hello, Mihail, how are you?
Hello, good evening. Thank you for the invitation.
Wow,
I'm very excited to join this event.
Wow, incredible presence. Thank you for coming. It's a pleasure to receive you. And feel free to present yourself, your channels, and take your time.
Thank you very much. My name is Mikhail Matev. As I already said, I'm from Bulgaria, so far from Brazil, but now world is too connected. I work on Microsoft Azure from the beginning, and last several years, I work mostly in direction related to AI and data on top of Azure, like architect, consultant in many different projects. So yeah, I'm very happy that I can join this event. Also, I'm organizing many events in Bulgaria. We have small country, but trying to support the community, and I'm very happy that can join this event now.
Wow, thank you. And we can see your screen right now. And if you want, feel free to continue the presentation. Okay.
Okay, thank you very much. And then let's start. I will talk now about how to create agent AI applications, or the session is from prompt flow to agent. Natural steps, how to make it, what is specific. Maybe for some of you, there are a lot of non-context, but there are also some specifics that often people, even me, forget. So I try to summarize, and I will have also several examples. So quite often now we are talking about agent and agent AI applications. But what is different? What is specific? How exactly it works in the context of general vision for agents, and especially how it works with Microsoft Foundry. How is the new name of Azure AI Foundry? I will try to describe in several slides and several samples for less than 50 minutes, and hope we will have also time for Q&A and discussions. If some of you later has questions and time is not enough, feel free to ping me via email, social networks, LinkedIn. I will be happy to provide information that is related to my knowledge. Samples and slides will be shared. So yeah, hope that this will be helpful for all of you. Why we are talking about agents and what is the difference between traditional prompt flow and agent architecture? The most important difference is related to orchestration and dynamic reasoning. Similar functionalities, like those offered from agents, are not something completely new, because agents implement a set of tasks that can be managed independently without additional involvement from operator, from applications that we name agents. In the past, more simple, not so smart applications that can do similar things existed, but some of the most important things were related to how we make orchestration. If orchestration is with clearly described flow, deterministic, or it is something that covers more things, unexpected cases, edge cases, like now is with agents and agent architecture. Some of the important things is to know exactly what we have additionally using agents related to what we have in application using AI as a service or all these models that we access remotely. There are several things. One of these specific things is actually options to have additional actions. That means we can have a flow that are outside of the agent, and we can make connection between our application, our agentic application, and different flows that can make possible agents to talk with different applications, new applications, modern applications, or old applications. This is something that we can make almost out of the box using modern agents. But in the context of agents, Microsoft offers a specific setup where we can minimize the work and to make several activities simple. So, connection with external systems, management of memory, instructions that actually helps more and can do more things than instructions that we have for LLMs. We have additional tools that can be also used. We can attach storage. We can use rack almost out of the box. We can have also storage of the secrets. We have security. And of course, we can have model that can use different models. I mean, we can have agent that can use different models. We can change the models, but interface for the agent can stay the same. I started with things that agents can make with other systems. This is really one of important things that is, of course, possible to be done manually using application, talking with large language models and having logic to call other applications. But here, everything is simpler, easier, and we can make it more efficient, faster, and also with the help of AI to cover more cases. Usually, connections with other services can be done in two different ways. One, the more general, is using OpenAPI. We will talk a little later about OpenAPI, the standard that is supported from agents in Microsoft Foundry, and it is really easy way to connect the agents with other systems. If other systems are able to expose HTTP endpoint and we to trigger some flow calling this HTTP endpoint. Several Azure services are available without need to make specific OpenAPI interface. You can call functions, AI search, file search, and also you can have code interpreter if it is needed to make some calculations. One interesting thing is using of browser automation and options to use also browsers and their functionalities in similar way, like maybe many of you saw in the past. OpenAI introduced nearly 1 year ago OpenAI Operator. Now OpenAI Operator is part of OpenAI Agents, where if you write chatgpt.com/agent, you can make interaction in such kind of agentic mode, and to see what the agent is doing, seeing the browser, and also if it is needed to add some credentials or other specific choices, you can take control if you want. We can have also grounding search that is integrated in Microsoft Foundry to be possible to have search worldwide empowered from AI plus all these functionalities. So I will go ahead explaining few things about Open API. The most important here is that we can have different clients, and we can make model to understand information using specific internal flow with normalizer. It is something that we should not do. It is something that is offered from the agent. But agent can communicate with other applications that expose endpoints using Open API. Open API supports um, Open API 2 and 3, but 3 is recommended. I will show in the demonstrations a little more information. Now I'm going to one specific detail that we have developing agentic applications with Microsoft Foundry, but for other applications usually are not out of the box, usually using Microsoft Foundry and agents. We have support of managed identity and integration with Microsoft Entra, which is very important when we have integration with enterprise applications. Again, some samples will be provided a little later. Usually, this integration is straightforward when we are calling from the agent other applications, and there are a little more challenges if we have, for example, um, single page application or web application that should call our agent. In this case, we need to build a simple backend and to have additional functionalities that also I will cover in the samples. When we talk about API design, usually the general principles for clear API and detailed descriptions are valid here, and we need to have, of course, specifics that are related to the interfaces of other applications that need to use interaction with API. I will, with OpenAPI for agents, I will demonstrate this. We need to be sure that when we are calling the API, we have consistent results. That means from one side, we have AI enabled service, and sometimes AI can give different results. But we need to build API in a way that other applications should have predictable information like structure of messages when they communicate with these agents. Usually contracts are not very complex. Again, I will demonstrate after that. The most important is actually to describe the content and what will be the schema of the endpoint that will be called, and responses. There are also some things that many people um, realize when start to build applications related to rate limits and also related to load on some other services. What I mean, from one side, AI agents can have a lot of calls and some moments to base LLMs. It is something that is hidden for us, but sometimes agents can send um, different amount of information, sometimes with spikes, to other applications, to other endpoints that are connected. And this is something that is managed from AI. It is not fully deterministic. Sometimes it's possible to have detection from systems that protect other platform, other endpoint, and to think that this is the DOS attack or something like this. This, of course, when we consider this, it is possible also to make instructions and agents to have predictable behavior. Other systems that have integration with agents, in any case, need to be considered for possible cases. One another thing is related to observability and tracing. It is absolutely doable to have this based on communication via Open API, and you can have for all these messages and telemetry tracing that will help to clarify if you have some problems, some issues, some optimization is needed, or some errors. So, going into other systems, I will demonstrate after that several types of integration, but more often for fast implementation, we can use no-code solutions to implement flows between agents and some other systems. For prototyping, Power Automate is maybe the best fit because we can have in Power Automate triggering using HTTP and call. We have some logic. We can send information to other systems and to implement integration in this way. Of course, this is when we are integrating LLMs with some other functionalities that are up to specific tasks. When we integrate front end or some UI with agents, usually we need to have slightly different approach because of the security and specifics of the messaging flow. When we are talking about Foundry, um, the most important is that using agents, we actually have access to different functionalities under one umbrella. One project where you can have search, access to LLMs, and using agents. We can forget about specific LLM, specific functionalities. Agent will do this for us. So the overall complexity of applications will be lower, and we can make the things more reliable, more clear, easy for support. Usually when we have some flows, the standard situation is we have some request. We have after that interpretation of intent from the agent, tool invocation, and after that, this tool need to do the rest of the work and to send response. We can have, of course, this in different scenarios. I will show you scenarios where, for example, we are summarizing some information into documents, sending email, but we have actually no limitations. Everything can be done using the same approach. Um, you will see conversation that is similar to something like flow that I show. The most important is security, authentication, input validation, and to be possible to make tracing after that for possible issues, optimization, errors, and to support the application easier. Most of considerations for agentic AI applications are um, not only for such kind of applications. We need to have, again, options to have fast response, exponential backoff. We need to have option to support durable state. In this case, usually we are using platforms like Cosmos DB or different search services, but search services have some limitations regarding to the size, regarding to the high availability, and also are a little more expensive. Now I will go into the last several things that I want to share, and we'll jump to demos. So when we have agent, we need to remember we need to have um, such kind of applications when we want to use um, independent applications with non-deterministic flow to manage the whole tasks. We can integrate such kind of applications relatively easy with other applications. We are able to use integrated search and to empower the agent with retrieval augmented generations almost out of the box. And we can use code interpreter to solve some tasks inside the agent. So many things that we can do independently, but our application will stay too complex. I will prefer now, despite that we have several more slides, to switch to some demo part and to demonstrate how we can make applications starting from non-agentic with similar functionalities. And after that, we will switch to more modern approach having these agents. First, I will start with something that is, at least for me, maybe basic and clear, and it is how we can use from different flows open AI and different LLMs. I have for this scenario the following Power Automate flow. Again, I'm making this implementation with Power Automate mostly because it is simple, not much code, it is easy to understand the concept, and we will be focused on the main things instead to go deep into the code for this short time. But we can implement in different way with different technologies all these things. So let's see what we have now in this application. Uh, just 1 second to see. Yeah, this is the application, sorry. We have the following. We have analyses that are done from AI based on images that are uploaded somewhere. There is initial HTTP end call. After that, we have parsing, sending preliminary email. This is just for scenario. Notifications can be done in different way on different stages of the flow. After that, we have additional call to open AI. In this case, this is the LLM that is GPT-4o, I think, in the example. We are getting here information related to the image. Image is taken from storage and already serialized. After that, information is parsed, and we are saving response and information about image into Azure AI search, in this case, in one index. So quite often we have such kind of scenarios for the last 3 years, from the first time when LLMs stay popular and started to be integrated in different systems. And it is actually independent task that can be done, but for this situation, we have clear deterministic flow, as I already said. We can make the situation more complex, calling the endpoint from another tool. Usually, I'm testing such kind of functionalities with Postman or another tool that can simulate initial call, and after that, of course, make the real integration. So initially, I'm getting um, information from our LLM, what is the image description. After that, I'm sending notification via email, and after that, I'm saving information into Azure AI Search, making call to embeddings endpoint. I think in this case, it is Cohere endpoint, also LLM available in Microsoft Foundry. Let's see how it works. So first, I need to check if my flow is already turned on. Okay, and I will make a test simulation manually or automatically with existed values. It will take maybe several seconds to see the whole scenario. And after that, I will show you how it works in similar scenarios using agentic application. Now, what we are calling the API is similar to what we can get calling the LLM with native interface, I mean standard interface using Microsoft Foundry, or directly with ChatGPT, for example. What is the difference? When we are using API, we have no so strict limitations about the tokens that can be used for specific step in the prompt, and we can have better and faster clarification of some cases with the help of LLMs. Now, because we are still waiting, I will go to one existing already run to demonstrate how everything works. So we have initial call, we have here in the request body in the input specific information that is for the image. Parsing is done with several steps, and after that we have saved into image index. This is the name of the index of the information. To see where the things are saved, I will open also Azure Management Portal, and in Azure Management Portal, I have already created AI search and index. Indexes, in this case, need to be created in advance with specific structure when I have something like general search, because we didn't discuss the specific instance. You can see information that we have already saved in the index. And usually we have for specific fields here also these embeddings. Embeddings are multidimensional vectors with different numbers that describe the image. And after that, we can add logic to have comparison between existed already results and new results. In general, it works, but looks complex. Small parts of our application need to be implemented with relatively complex logic, and imagine if it is production and need to be also implemented with some developing technology, it will stay more and more specific. But we can do something that is simpler. For example, we can make agents. To have the full power of agents, we need to have several steps that I will not implement now because of limitation of this timeline, but I will explain. We need to create a project in Microsoft Foundry, and we need to have hub projects, and we need to use agents inside it. When we have this project, we can create agent using standard functionality for new agent. After that, we can choose deployments that need to be used for our LLMs. We can have in the whole project one or more models. We can change it later. We have unique ID of our agent, and we have instructions that we can make with human language, but of course specific logic, to let LLM to process some logic and to call some other applications if it is needed. After that, we have agent description. I will show already implemented. Now I'm demonstrating how it looks in general. So yeah, before agent tools for actions, we can add knowledge. Knowledge is what we are using like additional information. This is something that goes into the context of our agent. It is not cheap to make fine-tuning of models, and full training is extremely expensive. But for many functionalities, we can have lower price and also better results using so-named retrieval augmented generation or RAG. Using knowledge option for agents, we can make these um, almost out of the box. We can add information with Azure AI Search. We are able to add files. We are able to add information from SharePoint, Fabric, and also custom search from Bing. And this information will be used in the context of um, our threads that we have with the agent. So this is one of the things. I already have such kind of prepared knowledge in ready for use implementation. So I will not make it now. I will add um, 1 second, not connected agents. I will demonstrate how to add um, additional tools for actions. We can implement here functions, Azure functions, logic apps. These can be also with Power Automate directly, but I will demonstrate how it works with general OpenAPI endpoint where we need to add name, we need to add description, and after that we need to add schema. For the schema, there are instructions in documentations. You can generate schema. I will not make this now. I will show you already created agent that can be used. So what I will demonstrate is one simple application that are creating RFQ, request for quotation, and our agent manage the conversation and clarification of parameters. After that, is sending the information to Power Automate flow, but to see more details, we are making this with OpenAPI endpoint. Power Automate flow is making some summarization and sending email. So we have very, very simple demonstration how the whole flow works. And this is something that maybe will be interesting. Also, before to make this, I will show something that I prepared. I prepared existing RFQs and also quotations, requests for quotations and quotations that I added into Azure Search Index and put this index to be hybrid. That means we can search by both vectors and keyboard because in keyword because if we have information from existed solutions, we can find it from both. We can have answers using the full power of this technology with vector search. So this is connected, no need to edit, and we'll demonstrate how it works the integration interface for OpenAPI. You see here we have actually OpenAPI, we have some base URLs, and after that we have description of paths, what exactly need to be done, and after that we have queries that are described in this endpoint. That means we have uh, big flexibility to implement OpenAPI integration with different endpoints because the schema allow us to make this with almost any kind of endpoint. So let's first, before to run it, to show in our Power Automate that I try to demonstrate. Also, another thing that will be called. I have one additional flow used for this implementation. Okay. Okay. Yeah. So what I have here, I have a trigger that is the same like what we have in the endpoint. Just in the endpoint, there were two parts: the base server URL, and after that, we have additional part for specific actions. Here is the whole URL. We have the schema. Schema is created based on request. That means usually you can have no idea what is the exact schema, but based on the request, when you create the flow, you can adjust it. You have after that several transformations because I'm sending in JSON structure of the RFQ. After that, one collection, and after that, I'm creating HTML table, adding this HTML table into mail client, and after that it is sent. So let's see how it works. First, and this is the natural way, we are testing such kind of functionality into playground. Let's try to make it a little bigger. And I will say generate RFQ. How the agent knows what to be done. This is something that maybe I missed to explain. Instructions. I will make one copy of data from here into Notepad to see how instructions looks. Of course, we need to learn some things. We need to have a little base knowledge, but all explanation is with human language. Primary intent, what is needed, memory policy, trigger, what kind of phrases will be done, validation rules, what need to be clarified, and examples and response. Also, we have calling of the endpoint described here. So, going back to our scenario, reuse last RFCO. I think we have 5 minutes. So we are seeing preloaded details, but preloaded details are not with clear information. I will try to add some information. For example, now Christmas is coming, and I will put it in a little Santa Claus style. Santa Claus, snowman, quantity, delivery before Christmas. Let's try to make this. So agent is thinking. And I say no optional fields. Proceed RFCO. And I will say proceed with RFCO. And RFCO is delivered. How we will check this? Because of course it is important to demonstrate that it works. So I will show you, because this flow runs a few seconds ago. This is actually the executed RFQ, and I will demonstrate also in the mail client how it looks. It looks, of course, very simplified, something like this. I added just several parameters. So it is some functionality that is implemented outside of the agent, but agent can call it, which is actually interesting. 1 minute maybe for the last things. That's pretty nice, but we need to have usually custom applications. And to have custom application, I already created one application that contains single page static website plus .NET, simple .NET backend. And I will run the application, will run also the front end. I'm doing this here from my computer, but it could be deployed, of course. When we have such kind of applications, we need to have for real communication that allows multi-threading, not in the context of multi-threading applications, but in the context of a messaging model of agents and communication with agents and getting messages, sending, make the full functionality, we need to have a simple backend. I have no time for this, just will show how it works. Usually, yeah, we need to have some authentication, MFA is required. And now you will see the whole application. It is in raw format to see how messages works, and it is not polished, but I think will be pretty fine. So, and here we are using the same last tariff queue details and starting to work in a similar way like it works using playground. So step by step, we can have fulfilling of this RFQ and to proceed in similar way. I wanted to show you how usually we make the applications. Usually we need first to clarify the prompt. We can have different parts of the overall flow and logic. After that, we are going to agents. Already when we know what to do, agents are much more flexible, can make the things faster, test agents first in with the interface that is in AI Foundry. After that, we are adding custom interface with auto authentication and functionalities that we need to have these agents with UI that can be different, can be integrated anywhere, and to have the whole power of AI agents in our solution. If we need to have several agents, multi-agent application, we have two options. The more straightforward is we communicate in our application with one agent, and this agent is like orchestrator. We can, of course, call different agents from the application, but then this architecture is not so efficient because the complexity is going into our application. So that's maybe the most important day I wanted to share for this limited time. Big thank you for invitation for this awesome event. And I'm not sure if there are some questions. If there are some questions, I'm available to answer it now or later in the best time for people who join the session.
Wow, wow, Mihail, fantastic. Incredible talk, valuable content with a step by step guideline. I wrote down here when you said security. It's an important topic too, right?
Exactly. This is something that Microsoft Foundry brings, and especially Microsoft model for agents. Agents by default use the highest security and integration with Entra. This is the reason to be also recommended because calling directly LLMs, we can proceed in different way with different APIs, especially if we are not using Foundry. But here, everything is secure for organizations, for enterprise applications. It is much, much better than to play with keys and to have integration where we need to build around the security in custom way.
Wow, okay. And if you were to give one piece of advice to people starting to study about agents, what would it be?
First, learn the concept. What really agents do and why we need to use it, to take the advantage, not just to make it because it is modern. And after that, start with simple scenarios. Make the things modular. Make the application first with one agent. Connect UI with one agent. And if you want after that, you can add many agents behind this and to use only one for orchestration with interfaces. This approach is also the recommended from Microsoft and all software experts. I think following these steps can make faster, easy, predictable, simple, reliable applications.
Wow. Okay. Wow, incredible, incredible. Thank you, Michael, again. Incredible content. And maybe see you next year on Seattle MVP Global Summit.
For sure, looking forward to meet you. And yeah, it is pleasure for me to join this event. And always I'm happy when I can share more or less from the experience with people who are interested in this.
Wow. Thank you again. And see you. And bye-bye. Thank you, Michael.
Thank you. See you.
See you. Uau, pessoal, muito bom, muito legal, muito bom mesmo. E vamos encerrando agora, né, o evento. Acho que realmente foi muito bacana esses 2 dias de transmissão, de conteúdo, enfim, recebendo diversos convidados, não é verdade? Tivemos aí diversas presenças ilustres que reservaram um tempinho para estar aqui com vocês, né? Então é assim que a gente se despede, assim que a gente encerra uma homenagem. Big thanks for all the speakers. Foi realmente muito, muito legal, tá bom? Todo o material fica disponível, fica gravado no site do evento. E, é claro, um bom final de ano a todos, não é verdade? Porque estudar é muito bom, descansar também, né? Acumular conhecimento para melhorar a sua carreira, os seus projetos, enfim, cada colega que esteve no evento com um objetivo diferente, tá bem? Então, muito obrigado a todos e até a próxima. Valeu!